All right, hi guys. This is part 2 of my videos on transformations for geometry class, and in this one we're gonna look at reflections and rotations. In part 1, we looked at translations. So in this image here that you can see that you could take a geometric shape. You can maybe you're making an animated movie or something like that, and you wanted to have a reflection of a mountain. You could create shapes and artistically draw them in, but to get that reflection, we're reflecting across this line. This image right here gets reflected across that line over to here, and that's a place where maybe you would use reflections. Okay, so name the type of translation or the transformation here that's shown in that picture. Hopefully you see that that is also a reflection. Okay, so let's look at an example here. You are drawing a pattern for a wooden sign. Use a reflection in the x-axis to draw the other half of the pattern. So we're going to take this set of coordinates here. Let me draw that in a little bit better. We're going to reflect that over the x-axis. And then let's look at what happens to all of those coordinates. So when you reflect this point reflected over that line, it's on the line, so it goes nowhere. Same thing with this point. This point up here is at 1, 4. When you reflect it, it drops down to here, so this is 1, 4. The reflected point is down here at 1, -4. Also, let's look at this point right here. This is the point, or this one. This is 1, 2. When you reflect it, it reflects down here to 1, -2. And keep going here. This point is at -1, 2. When we look at the reflection, it's down here. The x-coordinate doesn't change. It's just the y-coordinate that changes, and it becomes the opposite of the original image. So if you look at each of those, 1, 4 went to 1, -4. The x-coordinate stayed the same because you're not moving left or right, you're going downward on that same x-coordinate, but that y-coordinate will change to a negative. So you multiply the y-coordinates of each vertex by -1 to find the corresponding image. So this is for your notes. In coordinate notation for a reflection, it looks like this. You multiply each y-coordinate by -1. So your xy is this is your pre-image or your original. And then if you want it to reflect over the x-axis, you're going to take the same x-coordinate, you leave the x-coordinate alone, but you do the opposite y-coordinate. So for example, if we have a point like 5, -7 and on the original, and you want to reflect it, the x-coordinate stays the same and the y-coordinate becomes the opposite, or 7. So for reflection in the y-axis, which means it's going to be flipping this direction instead of this direction, you're going to actually multiply. So for y-axis reflection, you're going to multiply the x-coordinate by -1. So your xy coordinate, so if I take that same point, 5, -7, and I reflect it over the y-axis, the x-coordinate changes to the opposite side, so it becomes a -5, but the y stays -7. Okay, so let's reflect a figure in the y-axis. If you have the points in blue and you want to figure out what their reflection coordinates would be, you just take this, the notation that we're using is if it's a reflection in the y-axis, your xy values now become x -y. So -1 would stay, -1, 0 would stay -1, 0 because the opposite of 0 is still 0. But if you have a point like 1, 2, it's going to become 1, -2, and so on. 5, 0 stays 5, 0. -1, 2 becomes -1, -2. 1, 4 would become 1, -4. And if you plot all those points, you will see that you will get an image that is reflected over the x-axis or over the y-axis. That would be how you could check your answer. Okay, so let's do it. -1, 0 becomes -1, 0 because the opposite of 0 is still 0. And then 1, 2 becomes 1, -2. And 5, 0 still stays 5, 0. So let's plot the blue coordinates, and then we'll do the red, and we'll see that it's a reflection. Okay, so -1, 0, 1, 2, and 5, 0 is a triangle if I connect those dots. Then let's do the red points is still -1, 0, 1, -2, and then 5, 0. So, was that a reflection in the y-axis? Absolutely not. That was my mistake. This should be in the x-axis. Hopefully you caught that. Oops. All right, so change that in your notes. This, if you change the y-coordinate, this is a reflection in the x-axis. If you change the x-coordinate to its opposite, it's a reflection over the y-axis. All right. So show the location of the image, the purple image, after the transformation, xy goes to x negative y. So, get my picture out of there. We'll go purple here. -1, 6, if you perform this transformation, is going to stay -1, but then the y-coordinate will become -6. -5, 1 is going to become -5, -1. -8, -1. -6, -5, and -4, -4. So if I plot those, -1, -6 is down here. The next point is -5, -1. And then -8, -1. -8, -1. And then I have -6, -5. There's -6, -5. And -4, -4. So it should look something like that. If I take this figure and I flip it up, down, and this, since this is one unit away from the x-axis, this would be one coordinate down from the x-axis, and so you can see that that image is truly a reflection over that line. Okay. Now I want you guys to do this, figure out your new coordinates and what type of reflection this is if we take the opposite x-coordinate and keep the same y-coordinate. So go ahead and pause the video and do that. Get all those coordinates and then graph them. Alright, so your coordinates should become +1, 6, +5, 1, 8, 1, 6, 5, and 4, 4, which I plotted and connected the dots over here. And if you look at this figure, if I flip it instead of up, down, this time I flip it to the left, right, and this point, -1, 6 would become +1, 6, and you get your reflected image. And when I'm looking at this, I plotted a point incorrectly. You can tell because it does not fit the shape. -4, 4 becomes 4, 4, which is right here, not where I had it. So it should look like that. Just be careful when you're graphing. That's the point there, I guess. Okay, so types of rotations. So some of the common types of rotations, a lot of times, at least in this class, you're going to have the center of rotation located at the origin. And common rotations are 90 degrees, 180 degrees, and it can be clockwise or counterclockwise. But for 180, it doesn't matter if you're going clockwise or counterclockwise, it'll turn out to be the same either way. But 270-degree rotations are also common. 120 is also common, but a little bit less common. If you look at this first graph here, it's a 90-degree rotation clockwise. Move the center of rotation at the origin. It would look like that. So you're just taking the whole figure and moving it over like on a clock, 90 degrees. And a 180-degree rotation looks like this here, and which is the same. No, it's not the same. So this is about the center of rotation at the origin. That's a 180-degree rotation. But if you move that center of rotation to a point like right here, -2, 1, then it just is going to move around that point instead of around the origin. And so it'd just be, it would look like the blue figure in this graph. Okay, so let's see here. Graph AB and CD and tell whether it's a rotation of AB about the origin. If so, give the angle and direction of rotation. So if you look at this, let me scroll down here. So here's my AB in blue and then CD's in red. And if you look at that, it is indeed a rotation 90 degrees clockwise. I want you to think about, like, if the original is the red, we'll call this image A, and this is my, this is the pre-image is A, and then instead of calling it B, we label it A prime, so that we know that that's the image. So what type of rotation is this? And if you think about it, it has gone 180 degrees. So it's a 180-degree rotation, and it doesn't matter if you go clockwise or counterclockwise. In general, if you have a type of rotation that is as follows: 90 degrees clockwise, if the red here, if XY is on the pre-image, then what happens to the coordinates, if it goes 90 degrees, is the X and the Y's flip-flop and the X becomes negative. So you can, if you're having trouble with deciding what degree of rotation it is, you can check this chart and make that decision based on this. So, and like, you write down all your pre-image coordinates, write down your image coordinates, and see if it fits any of these forms. So if it's a rotation of 90 degrees counterclockwise, then the Y becomes a negative. The X and Y still flip-flop, but the Y becomes negative and the X stays positive. And then 180 degrees, both the X and the Y are exactly the opposite, but they don't switch places, just opposite. 270 degrees is very much, 270 degrees, if you go 270 degrees clockwise, it's the same as going 90 degrees counterclockwise. And so you end up with the same thing as if you go clockwise. If you go 90 degrees counterclockwise, it's the same thing as going 270 degrees clockwise. And then same thing with the counterclockwise rotation. If you go 270 degrees counterclockwise, it ends up being the same rotation as 90 degrees clockwise. Okay, so that is that. Bring your questions to class on the assignment that you've been given for transformations, and we will go over the questions Thursday. All right.